This is an example on similar figures. Find the ratio of the lengths of corresponding sides of figure M to N. What these instructions mean is that you have to find a ratio. A ratio means you're going to set up a fraction, and this fraction is made up of the lengths, or of these measures, of corresponding sides. Okay? And it has to be from figure M to N. That means from figure M to N, which means we need to start at figure M, okay, to write these ratios. So before we continue, remember in the last video I taught you how to find corresponding sides by following the order of the letters in the similarity statement. But notice in this problem, there is no similarity statement, but I can create one. When none is given, I can create one and then use it to find the corresponding sides. We also have another option which we will discuss at the end of the video. But for now, I want to teach you how to find or write your own similarity statement. These arcs that you see inside of the triangle we discussed, that they mean congruence. That means that angle A, which has one arc, is congruent to angle D of the other figure, which has one arc. Okay? When we say that they are congruent, that will also mean that they correspond. Because I know that the figures are similar, already I know that corresponding angles are congruent. So they're showing me congruent angles. It must mean that angle A and angle D correspond. Same thing goes with angle B and angle F. They are corresponding angles. And angle E and angle C are corresponding angles because they are congruent. So with these symbols, I can try and write a similarity statement. In this triangle here, I'm just going to go in order. I'm going to say triangle ABC. Triangle ABC is similar to triangle. Now over here, be careful. Don't assume it's DEF. We have to make sure by looking at the order of these letters and create the order in these letters. So notice that the first letter here is A, and we know that A is congruent to D, so A corresponds to D. So that should be your first letter. Okay, the first letter in your set. Now the second letter is a B. So I look at B, and B has two congruence arcs. That means that angle B is congruent to angle F. That means angle B corresponds to angle F. So my second letter should be letter F. And letter C, which is the last letter in the series, three congruence marks. E has also three congruence marks. That means C and E are congruent, which means that angle C corresponds to angle E. There it is. So they didn't give me a similarity statement, but I created one. Why do I need this? Because I need to look for the corresponding sides. That's what it says here, corresponding sides. So here's what you do. To create a ratio, of course, we start with a fraction. There it is. Okay, there's my fraction bar, and it says here to start on figure M to N. So that means M to N. Remember that a ratio can also be written as using the word to. Okay, so I'm here at figure M, and let's say I want to start with side ED. I need to find which side in this triangle corresponds with side ED. Okay, so we said we're going to start with side ED, so I'm going to write ED, and the denominator is going to have the label of the corresponding side to ED. Let's look at our set of letters here, and you can see that ED, the first and the third letter, make up the segment ED. So the corresponding side on this figure would be CA. Okay, and then CA right there is the side that corresponds with ED. So I'm going to write CA. Okay, that's one ratio. So it says find the ratio of the lengths of the corresponding sides. So I have three lengths. That means I need to find three ratios. Okay, let's do the first one. ED over CA. I'm going to write equals. because I want to find the ratio in numbers, not in letters. So the length ED, I substitute ED for how much it is for its length. So the length is 4.2. I'm going to write 4.2 in substitution of ED. And then for CA, I look at this figure, CA, and this side, CA, measures 6 inches. Okay, there it is. Now in class, we talked about these decimals and the fractions, and one little trick to get rid of this decimal is if you need to move it one place over, then that means you would need to multiply by 10 in the numerator and in the denominator. And we use this just to get rid of that decimal. The top becomes 42, the numerator, and the denominator becomes 60. Here's your ratio, and what you need to do next is simplify it to lowest terms. Notice that between 42 and 60, there's a common factor of 6. So if I divide 42 by 6, I get 7, and if I divide 60 by 6, I get 10. And here is the ratio of the corresponding side, 7/10. Okay, that's one side. Now let's do another side. And since the figures are similar, I already know that these ratios are going to be the same. So let's pick another side. Let's do side FE, this side here. Okay, and remember we're starting with, always start with M because it says M to N. So FE corresponds with who? Well, let's go to the statement. Notice that FE are the last two letters, so BC, which are the last two letters in this statement, is the corresponding side to FE. So here, BC, this side BC, corresponds to FE, so I write FE to BC, and now I substitute the values. FE is 5.6 and BC is 8 inches. Again, I'm going to multiply by 10, numerator and denominator, so I move this decimal point once over. This becomes 56 over 80. And that equals, if we simplify by 8, 8 goes into 56 7 times, and 8 goes into 80 10 times. Notice how we got the same exact ratio as we did with the other two corresponding sides. And guess what? When we do our last side here, which is side FD, FD corresponds with who? Well, we go to order of our letters. Here's FD right here, the first and second letter, so that would correspond with BA, which is the first and second letter. Here it is, BA. Okay, so FD corresponds to BA. FD measures 8.4 inches and BA measures 12 inches. Again, we multiply by 10, numerator and denominator, to get rid of the decimal point. This becomes 84 and this becomes 120. And if we simplify this by 12, 12 being the common factor, 84 divided by 12 is 7, and 120 divided by 12 is 10. And there we have found the ratio of the lengths of the corresponding sides by first creating our own similarity statement and then using it to find which side corresponds to which. Okay? The second option you have is the following. The second option is, instead of creating a similarity statement, you can just look at the sides and the angles that they share. So for example, this side here, side AB, they share angle A and angle B. So I'm going to look on this figure for a side that shares the same angles. And I know which ones are the same angles by the congruence mark. So I have one arc here. This one has one arc here. This has two arcs. This has two arcs. Those two angles share side FD on this figure. And these two angles share side AB in this figure. So that means that side AB corresponds with side FD, okay? But let me erase that because the problem said that I had to go from figure M to figure N, so I have to start here. So FD corresponds with side AB, okay? Which is the same thing I had found here. And then if I want to see what side corresponds with this one here, this side shares side ED. Let's write it. Side ED, angles D and angle E share side ED. So this one with one arc and this one with 3 arcs, I look for it over here. Here it is, 1 arc, 3 arcs, and those two angles share side AC. And here's ED corresponds to AC. There it is right there. We had found it already here. And then the last but not least, look at side FE. FE, there's 2 congruence marks here with the angles and 3 here. And the side that shares these 2 angles is side EF. So EF will correspond to whichever side on this figure share the same 2 angles, which would be side CB. CB, and there you have it. We found all 3 ratios of corresponding sides. I hope this video helps you understand a little bit more. I'll see you in the next video.